Q presenter.
Alrighty.
Make sure your monitor is clean.
Of course my monitor's clean.
I'm just telling you, because they'll be able to see everything.
Well, they will and they won't.
There you go.
Alrighty, can you see my SQL Server 2016 security slide, Rachel?
I can. It looks like binary, but then there's some random symbols in there, and it's confusing to me.
Wow, you definitely get points for knowing binary.
Thanks. Yeah.
Good job. That was a fair. Alrighty, so today we'll, like I said, talk about SQL Server 2016 security. Lots of cool stuff happening in SQL 2016. For those of you who don't know, hopefully everybody's already aware of this, but for those of you who don't know, SQL 2016 launched just over a month ago, back on June 1st. Lots of really good stuff in there. But today we're going to cover just a small piece of it and talk about a few of the security features. So tons and tons of features in this update, but we're just going to focus on just a couple of them today. Real quick, just a little bit about myself. There's my email address and everything up there on the screen if you guys want to take that down, and any follow-up questions or anything like that you have that maybe I don't have time to get to today, feel free to shoot those over to me. But my name is Brad Schacht. I'm a data platform solution architect for Microsoft. I specialize in state and local government. Not Go Dodgers. Thank you, Eric. I see in the questions there. I am an avid Braves fan, which is unfortunate this year because they're absolutely terrible. But I actually used to work for Pragmatic Works. I still host webinars with them here every now and then. I still do a lot of community speaking. I'll actually, if anybody's down in the Orlando area, probably be doing SQL Saturday down there later this year, and I'm doing the user group there later this month as well. So I do go around and still do the community speaking stuff. So that's just a little bit about me, and let's go ahead and get into our session here today. So just a couple of little intro slides here before we get going. I'm going to go through all the little animations here. All the stuff nobody cares about. The piece I want to focus on here is obviously that second pillar there, the most secure database. So SQL Server in general has, over the past, that goes all the way back to 2010 there, has always been a very secure platform. And this release of 2016 just builds right on top of that with a lot of new cool features for the data masking that we'll look at today, the row-level security feature that's been added in now, and then extending the encryption functionality that we have built into the product. So the reason I bring this up is just say, hey, SQL Server, no matter what version you guys are running, SQL Server has always been a very, very good, secure product. And again, we're just kind of building on that legacy here with SQL 2016. A little bit of an interesting fact here about SQL 2016, and not necessarily just the security features, but the security features do play into this as well. But what a lot of people don't realize is how tested SQL Server 2016 already is. So everything has been running, everything for SQL 2016 pretty much has been running in an Azure environment for 6 months to a year, or maybe even longer depending on some of the features there. So all these security features, you can actually go out and do most everything that we're going to look at today inside of an Azure SQL database. And again, some of the security features here have been in preview for 6 or 8 months even in Azure. So even before the on-prem product launched, we've actually been testing these and using these with real customer use cases, or people have been using these in real customer scenarios up in the Azure environment there. So just know that this isn't something, all these features that we're going to take a look at, when they launched in SQL 2016 on June 1st, that wasn't necessarily the first time that anybody's ever seen these. They've already been running in Azure there for a while. Okay, Azure is also a really good place, if you don't necessarily want to take the time to spin up a new virtual machine with SQL Server on it or anything like that, because you can do a lot of this stuff inside Azure SQL Database. Azure's a great place to just go try out some of the features just to see how they work and do some testing out there. So this is going to be our agenda for today. Again, we're going to focus on the security piece here. There's 3 things we're going to look at: always encrypted, dynamic data masking, and then row-level security. So always encrypted got a lot of votes there, and row-level security got a lot of votes. Everybody said that they were definitely interested in all the topics there. Dynamic data masking is probably the smallest of those topics anyway, so it's probably good that had the lowest votes for who is most excited about that particular feature. But that's where we're going to start, just to get that one out of the way here. All right, so dynamic data masking, what this does for us is allows our applications and our users to query data but not necessarily get to see all the data inside the field. So something to keep in mind here is that this doesn't actually, dynamic data masking doesn't actually change the data that's stored on disk. A common use case for this would be, let's say that you have to call into a credit card call center or something. Let's say that maybe you have your credit card is stolen and you need to call and get it canceled. Well, one of the things that they're probably going to ask you is going to be something like, what's the last 4 digits of your social security number? Or maybe give me the last 4 digits of your credit card number or something like that, depending on where maybe you're calling to. So the key here is that whoever's on the other end of the phone there, I don't necessarily want them to have access to my full social security number whenever I call them and say, hey, I need to cancel my credit card or I need to get information about my account here. I only want them to be able to see the relevant data for that particular scenario, in that case the last 4. So what dynamic data masking is going to do for us is say, inside the actual database, we're going to continue to store my full social security number or my full credit card number, but when Susan on the other end of the phone asks me for my social security number, she's only going to be able to see the last 4. She'll just see, as you can see on the screen there with the credit card number, she's just going to see a bunch of X's and then just the last 4 digits there. So because we're not actually changing the data that's stored on disk or anything, that requires very few application changes. Okay. I've got a couple of slides in here, and I'll post these slides on my blog afterwards, so you guys can pull these down and take a look at them, because I'm going to go through some of these pretty quick just so we can, excuse me, just so we can get to some demos here as well. So privacy is kind of that scenario we just went through there. We want to make sure that we have the data available for somebody to be able to validate my identity, but we don't want to give them access to too much data. Okay, these could be things like, again, social security numbers, birthdays, credit card numbers, email addresses, just IDs inside of a database even. Excuse me there. But ultimately, it's a way for us to be able to protect certain users, not all users, but certain users from being able to see that data. Okay. So I mentioned a couple of these points already, but let me just reiterate some of these. Again, this is, when we say on the fly, what that means is, again, we're storing the full credit card number, full social security number, full whatever that field happens to be in plain text, key there is in plain text, inside the database system. Only when a user who is not allowed to see that data runs a query will it mask that data. So it's going to pull the data off the disk in plain text and the full text value there, and then after the data gets pulled off disk, it's going to then mask the relevant portion of the data and then send it over the wire to whatever user or whatever application happens to be making that call to the database. And I'll show you how that works and show you what that really means to us in terms of security there. So there's a question here that says, can we unmask data using queries? So the unmaskability is really granted at the login or at the role level. So if me as a user has unmasked permissions, then I'm always going to see the unmasked data. If you as a user do not have unmasked permissions, you're always going to see the masked version of the data. So you'll notice there, I also have a note here that says by default the database owner is unmasked. That is a key difference between the way this works and what you'll see with row level security coming up. So keep that in mind. So default, the database owner has unmasked on all the data inside that database. Again, any user that has unmasked permissions, they will see all the data in the database unmasked. This isn't down to a row level or down to a column level. You either have unmasked in this release or you don't have unmasked is the level of those permissions there. Okay? And again, I'll show you how all these kind of little things work together when we get to the demos here in just a minute. Okay, so you'll see there's this set of code here just shows you what the syntax looks like. Again, this is on a all of our masking is done on a column level. You say add mask with function. There's a couple of built-in functions like email and random, and then there's also one where we can do a custom masking, and I'll show you again all these little examples as we go through here. Okay, so somebody's going to go in, they're going to define what data is going to be masked on a column by column level. A user or an application is going to go in, they're going to run a query, and you'll see here they're pulling back name, social security, email, and salary. And you can see that we've masked social security, email, and salary inside of the table. So the user or application, again, no changes or anything like that. They're just going to go in, they're going to run that query, and whenever they get that data back, they're going to see, as we see there, the social security number is masked. They can only see the last two. The email address is masked. They're only seeing the first letter and then the .com or .net there. And then the salary, if you compare that over, you'll see that's a random number compared to the actual salary as you see there on the right side. Okay, so again, no changes. Kind of key there is no changes to the applications or anything to make this happen. It's all based off just the user login that's running these queries. So a couple of limitations here. If you have a column that's enabled for always encrypted, you can't do data masking on that, and that kind of think about the details behind that. That sort of makes sense. I can certainly answer any questions that people have about that, if there are questions about that when we get to the always encrypted piece. Computed columns cannot be masked. However, you can mask a column that is referenced inside of a computed column. So the computed column itself can't be the one that is masked, but if I'm referencing like first name or last name inside of a computed column, I can mask the first name or last name column. Okay, and then it's not available on file stream or full text indexes there. Okay, so let me pull up a VM here, and I've actually got a couple of scripts that we're just going to run through. And again, I can make all these scripts available on my blog afterward as well, because we're not going to have time to run through every single one of these pieces of data inside of here. So I'm going to go over to this database that I have here, and here's the table that we're going to be using for this particular demo. As you can see, there's a bunch of data inside of here that maybe we don't want people to see. You know, stuff like the org unit name is probably fine, the manager ID. Most of this stuff we probably don't really care about. But I've added a few columns over here just for example's sake. And you can see that maybe our email address, date of birth, and social security number, these are going to be the columns that we want to mask here. So I'm going to have a couple of little examples here. I have a couple of users that I'm going to impersonate to show you what this looks like for me as the database owner versus if we take a look at this as a user. Okay, so again, I've got the script here all commented out for you guys and everything. Again, so if there's anything that you guys want to take a look at inside these scripts, or if you have any questions, feel free to shoot me a follow-up email or anything like that as well. There are a few defaults that we have, and these are also referenced on MSDN, so you can go and see what the actual syntax is for doing a custom string versus a random masking and all those different things there. So what we're going to do here to start with is I'm going to, just to show you what the default option does, I'm going to take the org unit name column here, and I'm going to mask that entire column. I'm also going to do that on the employee ID column over here. The reason I want to do this is I just want to show you what the difference between masking an integer field looks like versus masking a text field here. So I'm going to go ahead, I'm going to run both of those commands, and then if I run the select here, you'll notice that the data is unmasked. The reason for that is I'm logged in right now as the administrator, which is currently the owner of this database. So because I have unmasked permissions, because I'm that database owner, even though this data is masked, I am still going to see it. So what I'm going to do here is I have this user ecross inside my database, and that person does not have unmasked permissions here. So I'm going to go ahead and run this command. And now you'll see that the integer value field with random, or with the default, defaults to just 0, and then the text value column defaults to just XXXX. Okay? So so that's the way that the defaults work there. One thing to keep in mind here on any of the masking, masking function that we use, whether that's default or some of the other ones that we'll look at here in just 1 second, is that we're never going to mask more, or we're never going to show more values here, more masked values, than what the column will allow. What I mean by that is if this is a varchar2 field or a character1 field, we're not going to put 4 X's here. So we won't modify the data that you get back from your mask is not going to ever overflow the size of the column here. Okay, so I'm going to go ahead and drop the masking on that on those couple of columns there. Let's go back here and see what that looks like. So both of those are back now. Okay. The next thing I'm going to do here is I'm going to mask the email. I'm going to use just the email function. Okay. So we're going to say add mask with function equals email. Guess I need to revert that again. Okay. Alter table, add the mask on the email. I'm going to execute this as that user again, and this time what you'll notice is when I look at the email address over here, it gives me the first initial, a bunch of X's, and then @.com. Just something to keep in mind here with the current implementation of this. If I were to go and update all of these email addresses to be .gov email addresses or .net email addresses or whatever, something else, you'll notice that those still always say .com. So in the current implementation, if you use the email function, it's always going to be first letter of the email address and then always .com. The underlying data itself, if I go run this query as just as myself, you'll see that the data is actually .gov. So if I did want that to display dxxxx at xxx.gov, then I would need to use a custom masking function, which I will again show you how to use here in just 1 second. Okay, so just keep that in mind if you do use the email function here and you don't have a .com email address, your users are always going to see .com. They won't see the actual email address ending there. All right. One of the other functions here, this is how we can do things with a custom function. This is useful for Social Security or date of birth here. I'm going to go ahead and add both of these in. And what this is telling us here, so for my date of birth column, what this is telling me is that I want to partially mask the data. I want to show 6 characters of real data. Then I want to show XXXX. And then I want to show 0 characters of real data at the end. So what that means to us is that I'm going to have something like month dash day dash the real numbers there. Okay. Or actually the other way around on that. So I'm going to show 6 characters. I'm going to show 02-08- XXXX is what that's going to come out as. So it's going to show me the birth month and the birth day, but not the birth year is what that's going to come down to. On the Social Security number, if I only want to show them, give them the ability to see my last 4, say I'm going to show 0 leading characters, and then I'm going to simulate a Social Security number here and then show the final 4. So let's take a look at what that actually looks like in my database. And when I run that, so there you'll see that now my date of birth, it's showing me the first 6 characters are going to be unmasked, and then it's going to mask the birth year. So we don't want our users to be able to see the year that somebody was born. They just want to be able to use their birth date to validate the identity. Same thing with the Social Security number. I'm going to call in. They're going to say, hey, validate, give me the last 4 of your social. This way my user, my support person on the other end of the phone, they can only see the relevant data for them. Okay. Again, here's just to reinforce that whole the whole notion that we're only going to allow you to that we're only going to show as many masked characters as your field allows. The Social Security field is a character 11 field, and if I put value in here that's going to overflow that field, and then I try to run this query, what you're going to notice is that it only shows me those first 11 characters here. Okay, so it's only going to say I can put A and then space, and then it's not going to bring back any data. That's really, really important because this means that it's not going to break all your applications that are used to bringing back only 11 characters or only X number of characters for whatever that happens to be. Okay. Here on the random function, what this is going to allow us to do on an integer field is it's going to say, I want you to show me a random value between the number 1 and 100. Okay, so when I execute this now, you'll notice the employee IDs, if you guys remember from previously, these actually started in the thousands. I think 1001 was the first value in here. But if you notice, every time I run this, like take a look at this employee ID, 40, 86, 25, I run this again, I get different employee IDs every single time I run this now. Okay, so it's going to give me a random value every single time I run this. Okay, the nice thing about this, but also something to be aware of, is that even if I don't have unmasked permissions, I can still run where clauses. So you'll see I'm looking for employee ID 1001, but it's bringing back employee ID 9. Keep in mind, remember what I said earlier, on disk we're actually keeping and we're storing the real data. Not until the data is pulled off and brought back to the user, and that's the key part there, not until it's brought back to the user am I going to mask this data. So if I have read access, I can come in here and I can type in any employee ID and I can run myself a where clause there. So there is some ability to hack this a little bit. Just know that it's not a, if you give somebody ad hoc access to the database here and they have read access on everything, this should not be your only security measures in place here. So yes, somebody absolutely could try a bunch of queries to guess somebody's social security number, and you probably should have some things in place to be able to monitor for, just massive numbers of queries that are going through and just running the same query over and over and over again with maybe just a where clause that changes on there. So just something to be aware of there. Just want to make sure that everybody's fully aware of that piece of information there. The good news here though is if I can't, there's no way for me to actually get to the underlying data. So if I were to run this query here and I create myself a temp table, what you'll notice with the temp table is that it actually puts in there the masked values. So I can't go and say, create me a temp table with this right here, and then it's going to give me all the unmasked data. So we do have some security measures in place from that perspective there. Okay, and then one last thing here, just to show you guys before we move on here. There is a query, so you can run this query, and you can actually see all the different fields inside your database that are masked, and it will actually tell you the masking function. I'll zoom in for you guys to be able to see that. So you can actually see which fields are masked, which table it's from, and which function is actually being used to do that. Okay. Question there says, would I be able to join out to a masked value, example social security number, and find matches that way? So if you have the ability to join a masked field over to another table and then pull unmasked fields from that table, that would give you information as to what data was in the masked field. That's kind of a round robin, kind of confusing way to say things, but yes, you would be able, as long as you have read access on both of those tables, you could absolutely join a field that you have masked in one table over to another table to try to figure out the data inside of that. So, again, all the data on disk there is going to be the same data that you have access to, and there's no additional security on from that perspective. Okay. Alrighty. I know there were definitely some other questions in there on the data masking there. I do want to move on to a couple other little topics here, but I will certainly take those questions and post a blog with all the follow-up to each one of those questions again, and put the demos in the deck out there as well. Okay, so let's talk real quick here about row-level security, and then I'll show you guys how this works. So row-level security is not something that's necessarily new. It is definitely something that's new to SQL Server. A lot of different scenarios. I'll kind of just go over here, this next slide here. A lot of different scenarios where this may come into play. There's there's a lot of things that we've had to do in the past to try to simulate this sort of logic too. So multi-tenant environments are a great example of where something like row-level security might be put in place. So let's say that I have a fact table, and maybe I've got information in there from 4 or 5 different banks. Maybe I'm centralizing all this data inside of there, or maybe I've got data from multiple departments or multiple divisions or something like that. But I only want the people from the manufacturing division to be able to see the manufacturing data. I only want the people from the marketing division to be able to see the marketing data, and so on and so forth. Row-level security is a great way to be able to continue to store that data all inside the same set of tables, but not necessarily allow the manufacturing people to be able to see the marketing people's data there. So that's one good example. Another one is business logic, as we point out there, business logic to determine which rows users are and are not allowed to select. But row-level security in SQL here is going to take us a step further as well and give us the ability to block people from doing inserts, updates, and deletes based on their role as well. Again, whether that happens to be the marketing versus manufacturing departments, or whether that happens to be, HR is able to see. HR is able to see somebody, all the data, but everybody else is only be able to see the data inside their departments. Those type of things can be handled with this as well. Analytics, reporting, and warehousing, again, this is a huge place where this becomes an issue in previous versions, because then you end up with things like where we have to build views that try to pull in the username, and then we go over and we match it up to a table and determine which rows the users are allowed to see. This is going to automate that whole, kind of take care of that whole process for us on a table by table level. But also we build those sort of things into tools like analysis services already. The nice thing about you doing this here inside the database engine is we now have a central place to manage all that. So we can leverage that same set of security inside of analysis services that we're using here inside the database engine. We also don't have to make modifications to all of our necessarily make modifications to all of our applications. We don't have to put that custom security into all these different applications when we can store it all in that one central place inside of our inside the database layer here. So couple of good reasons to put this inside the database and to build this into SQL Server as we've done here in 2016. Okay, 2 pieces that we're going to take a look at here. There's going to be a function and a policy. So all of this is actually built currently using table value functions. So you'll see that we have one function that determines the rows that we're allowed to see, and then we have a security policy on the table that tells us which function to invoke every time a user goes and does a query. Here's just a quick example overview of how this would work. In this particular case, we've got a nurse that's going and pulling a list of patients out of a database. So our policy manager is going to go in, they're going to build this policy into the database using the function and the security policy feature. And what this is essentially telling us is that for whenever a user comes in here and they select all the patients out of the patients table, they can only see the patients that are in their particular wing. Okay. So once we put that on, the user is going to go in, the user or the application, doesn't matter which, they're going to go and issue the exact same query that they would normally put out there. They're going to say select SAR from patients. No changes have to be made on that front at all. Once that query gets sent over to SQL Server, that security policy is going to be, it's going to see that security policy is on the table. It's going to apply that table value function and going to bring back the rows that are tied to the wing that particular, in this case, nurse is assigned to. Okay. This is, as we note here, this is the equivalent of adding just a where clause. So the overhead is the same as what you would have with putting a where clause onto a table. They can be very simple queries, and I'll try to show you a simple one and a complex one, but they can be very simple, or they can do multiple joins inside that table value function and piece together many different tables. Just keep in mind the performance of this is going to be directly tied to the performance of that table value function that you're creating there. So if you, the fewer tables, if fewer joins you can do, obviously the better off you're going to be there. Nice thing about the security policies is you don't have to drop them. So if you're in a development environment, maybe you just want to disable the security policy to go take a look at some data because you don't think your security policy is being applied correctly, you can just right-click inside Management Studio and disable the security policy, right-click, enable it back on, and it's as easy as that to flip that switch there. This is the key difference between the data masking and the row-level security piece that I mentioned. Members of the DB owner security group will still have their security policy enforced. So it doesn't matter what you are, whether you're the DB owner, whether you're part of the DB owner group there, whether you are the sysadmin on the server level, does not matter. You will have the security policy enforced here, just because it's going in and running that where clause and limiting the data as it pulls it off disk there. Okay, so let's go ahead and take a look at a quick example of this one, and then we'll get into the always encrypted feature here as we wrap up. Let me go pull in a query here for us to be able to run through. So question that came up here just now in the chat room says, if DB owner is enforced, then who can make policy changes or enable or disable? So you can still, just because the policy is enforced doesn't mean that you don't have the ability to go in and enable or disable the policy there. So there is, I believe, I have to go look on MSCN to see the exact name of the role, but I believe there is a role to be able to manage, to specifically be able to manage that, manage the security pieces there, so that you don't necessarily have to have access to the data, but you can still do these pieces. But the owner would be able to turn on and off those different security pieces there. So, but just keep in mind that that does apply to the entire table. It's not going to be user specific at that point. If you did want user specific security, or say, hey, anybody that's in the DB owner, you could build that into your security policy though, that says anybody that's in the DB owner group, they can see all the data. So if you just wanted that to be your kind of your default policy, you just need to build that into your table value function. And I'll kind of point that out whenever I show you the table value function here. You can reference users, but you can also reference groups inside of there. Okay, so I've got the same database here. So let me just refresh that. Go pull all this out because I think I'm still running under the other user. Okay, use oil and gas. Refresh the table. Okay, so let me just drop these just in case there's anything left over from last time I ran this particular demo here. And I mentioned, as we were going through the slides there, I mentioned that there were two pieces that we have to put in place here. One is the table value function, and the other is a security policy. So those are going to be the two things that we create here. This first example, I'm going to just do a really easy security policy, or a really easy function here that is just going to pass in the user that's running the query, and it's going to see if the user is in this particular table here. So if they're in this table, this is just a super generic answer example here, but if they're in this table, I'm only going to be able to bring back the record that is associated with my name. So if I'm running the query as across, I'll only be able to see this one record that says across on it. There's a couple other, I think there's 2 or 3 other columns inside this table that we'll have as well. So I'm going to create my function here. This function, again, just brings back and says, yes, I have access to this row, or no, I don't have access to this row, and then I'm going to create the security policy here as well on top of that table. And now, okay, so again, I haven't changed users. I'm still running, if you can see down here in the bottom right, I'm still running this as my administrator account. Okay, there is no data inside of this particular table, and this is a security table we're going to use here in a second, but there is no data inside of this particular table for my administrator account here. Okay. If I go over and I run this as ecross though, you'll see that I get 1 record back for ecross. If I were to run this as this other user, then I would get back the 1 record for that particular user there. Okay, so you can make it super generic and just say, hey, I only want to bring back the record that is associated with this one username, and that's a perfectly valid policy to put in place there. We can also in this particular example that I've got here, I've got this hierarchy, and I pulled this data. I don't want to take credit for this data at all. I actually pulled this demo data from a blog post that I found online. I can't remember the guy's name right now, but I'll post a link over to his blog as well, so that you guys can pull down this data set and you know, go over and check out his blog. He has some really great stuff on there about the row-level security piece and Always Encrypted. There's a whole app that he's built to go along with it that'll kind of give you an end-to-end demo of all these different pieces here as well. So some great stuff over there. Definitely don't want to take credit for all the great stuff that he put together. So I'll put that out on my blog with the answer to the questions and everything here for you as well. So what we're going to use here is this hierarchy to enable our row-level security. So what we're saying is essentially, if I have access to if my security is defined at the US division level, then I can see all the regions and asset groups and asset teams that are underneath. If my security is defined for a particular user at the region level, then they can see all the asset groups and teams that are underneath. If I'm assigned security at the group level, then I can see both of the teams in this case that are underneath it. And if I assign my security at just the team level, then I won't be able to see anything except for what is associated with that particular team. Okay, so that's the hierarchy that we're going to use inside of our data, and this is how that's actually set up inside of my database. So you'll see that each one of these users, they have their security defined at a level of that hierarchy. So whether that's the division, the group, the team, whatever that happens to be, and then of course the actual value that you saw inside of there. So you'll see inside of here somewhere we've got like the region and southern US. There's some in here, division and US. So this particular user would be able to see everything that is assigned to the US to the US region or division here. Okay. The way that is surfaced is through this well master table. So this is ultimately the table that we want to limit here. So if I go in as ecross and I run a query against this, I only want to be able to see the wells, well 1 through 100 in here. I only want to see the wells that that my security is mapped over to. So we're going to take a look at this data here and say, well, if my security is defined at the division level, then ecross can see anything that's under US. If ecross's security is defined at the region level, he's only going to be able to see all these that are assigned to northern or whatever that happens to be. Okay, so what we can do here, let me go ahead and clean up, make sure that none of that stuff is left over. And this is the function that we're actually going to use here. So what we're going to do is we're going to pass in the well ID. So anytime that I run a select star from this well table that we just took a look at, that well master table, I'm going to pass in the well ID, and then I'm going to go over to the using my security table here, that hierarchy SEC user map. I'm going to pull back the hierarchy value, and I'm going to determine whether or not the division for that particular user matches what's in the record for well ID. If their security is defined at the region level, I'm going to do the same thing. I'm going to check the region level. So we have one value here, or one scenario to check for each one of those different levels of the hierarchy. And then there are some users in there that are just allowed to see every piece of data. So if their hierarchy value inside the security table there is defined as all, then it doesn't matter what the division, region, group, or team is, then they can see everything. So again, keep in mind the performance of this is directly going to be related to how well you write these queries. This may or may not be the most performant way to write this particular one, but kind of gets the job done here just for demo purposes. This last piece here, there's a block policy, and I'll explain that one when we hopefully we'll be able to get over to it here in just a moment. I'm going to go ahead and put the security policy on here as well. But what you notice here is that I've actually got two different items here. I've got my filter predicate and I have a block predicate. What the filter predicate means is that whenever I select data out of my database from this particular table, so from the well master table, what that's going to do is it's going to pass the well ID field. So here we have the table, and here we have the column, So anytime I do a select anything from well master, it's going to pass the well ID column into the well security function, and it's going to run that function that we just took a look at. It's going to return a value that says yes, the user is allowed to see this row, or no, the user is not allowed to see this row, and it's going to return the appropriate data. Okay? So that's what the filter predicate is going to do. Anytime I run a select statement, it's going to say, hey, this user is or is not allowed to see this data, and it's going to, as the name would suggest, it's going to filter out the rows that I'm not allowed to see. The block predicate, on the other hand, is going to be used for things anytime I want to do an insert, an update, or a delete. You can add block predicates that says, you know what, this user is not allowed to insert it into the well master table, or we can say that the user is not allowed to update the data in the well master table if they're not allowed to see it, or we can say that the user is not allowed to update the data in the well master table if it's going to change it from a value they can see over to a value they can't see. Okay, and then we can, of course, also put a delete in there that says, hey, the user's not allowed to delete any wells, either that they're not allowed to see or they're not going to be allowed to delete any wells, just period. Okay, so block predicates are going to prevent users from doing particular operations, whether that's insert, updates, or deletes, and then the filter predicate is going to remove the rows, from the table here. Okay, the options here for, I think there's only one option for insert. I think it's only after insert. There is after update and before update. Both of those have a little bit different functionality. I mentioned one just means I can't update it if I can't see it. The other means I can't update it if it's going to cause me to not be able to see it. And then I believe there's also only one option in there for delete. And all four of those options are listed and explained on MSD, and I can put those in the blog as well, just for time's sake here. So I'm going to show you just a couple of queries. Again, I don't have time to go into everything. I probably do an hour and a half just on the row level security piece here. So I do just want to show you how this actually works. And again, I'll point you to some information and put some stuff on my blog that goes into some more detail here. So what I'm going to do is I'm going to select from the security mapping table, and then also from the well master table for this particular user. What this tells me is that this user is supposed to be allowed to see all the data. And if we look at the data that was returned, this is just aggregating the data up on the well master, from the well master table, you'll see that I get 10 records back. If you remember from my user mapping table, or from my hierarchy table, we had 10 unique records inside of there, so 10 US and international combinations inside of that table. If I go do the same query over here with H. James, you'll see that they're only allowed to see the data for international wells. So we see down here at the bottom that the user has only returned 2 records, the wells for Mozambique and the wells for Kenya. Same thing here with this particular user. Okay, this user is only allowed to see things at the region level, and they're only allowed to see northern US, so that's the only data that they get back. Again, exact same query being run for all 3 of these different users here. We just get back different data depending on what level their security was defined at. If I come in here and I give write access to all these different users as well, this user right here is going to say, hey, this user is not allowed to write because a block predicate conflicts with this operation. So I'm not allowed to, in this case, run an insert command. Even though this user has data writer permissions, I did not define inside my block predicate that this user was allowed to write data into my database, so it's going to block that operation. If I run it under this particular user, okay, it allows me to go in and write the record into the table. And if I go run this last one here, again, I can write the record into the table because they are defined inside this user exception table. Okay. Somebody saw a question in there, can users be security groups instead of just users inside the database? Can we define security groups? You can use the security groups in there as well, yes. Okay. Okay, and then last little example that I'll show you here for the update predicates here. So again, this user, they're allowed to see everything. If I go and I run this update statement, it's going to allow this to succeed. So it's changing, in this case, it's going to change the asset team that this particular well was assigned to. If I take a look at this user, they're only allowed to see northern US. If I try to run this particular query, you'll see that it tells me that no rows are going to be affected. The reason for this is it's an international well, and this person can only do it for the United States. So in this case, it's telling me no rows affected because as far as this user is concerned, they can't even see this record to be able to update the region over to Kenya. Okay. On the other hand, if I were to come over here and I run this particular query here, I'm trying to now change it. So let me take a look at this. So northern US, and the well that we're switching here is well number 2. So I'm trying to switch this from northern US over to a region that I don't have access to. That's why this is going to execute, and it's going to block. It's going to tell me that a block predicate conflicts with this operation, because I can, first of all, I can see the record, but it's not going to let me change it to a record that I can't see. And that's what the before update and after update predicates do for us. So if you guys remember when we came up here, we said after update is what we're blocking. So because I'm switching this over to a record that I won't be able to see, it's not going to let me make this change. If this were before update, then it would allow me to make this change, but I would no longer be able to see the record out the other end of that. Okay, so again, I've got a lot of other stuff here inside the script here. I'll post this all online for you guys. In the last few minutes here, let's go ahead and take a look at the Always Encrypted piece of 2016, and then we'll wrap up. Okay, so Always Encrypted does have a little bit of a parallel with transparent data encryption, just in the fact that they both use encryption keys. It's a multi-part key system here. The difference is that transparent data encryption is only encryption at rest, and it is scoped to the database level. Always Encrypted is going to be encrypted both at rest and in flight, and you define that at the column level. In backups, both sets, both transparent data encryption and always encrypted, both of those are going to have the data encrypted in a backup. However, TDE, again, is only encryption at rest, so it means as soon as the data comes off the disk, the data is going to be decrypted. The nice thing about always encrypted, again, is that it encrypts the data all the way through up to the user application, which means that we're going to drastically reduce the size of we're going to drastically reduce the size of the attack surface for your environment here. So before TDE, then you could get data when it was on disk, or you could get it when it was in flight. You add TDE in there, you get encryption at rest, so you can only get the data when it's in flight. You add always encrypted, again, no data even in flight can be decrypted there. So we're drastically reducing the size of that attack surface with always encrypted here. The key to this whole scenario is the fact that the data is decrypted or encrypted, depending on whether it's coming out of the database or going into the database, at the client driver level. Okay, so that ADO.NET 4.6 or later driver is required for this, and that means that that is going to be the piece that actually does the encrypting and decrypting of our data here. So again, key here, even DBA sysadmins, cloud admins can't access the data unless they actually have the certificate on their computer to be able to decrypt this data here. So, you know, it's the ultimate set of security there. Even those who are SAs can't get to the data. There's, you know, certainly some discussion that can happen around that as to whether or not you think that's the right way or the wrong way to go about that. But for this particular implementation, this particular release, that's the way this is going on. If you do have any kind of feedback on that, if you know how you'd like to see that, I'd love to hear some DBA folks and get their thoughts on that, because I know there's always a lot of discussion around that anytime I talk to DBAs about how they feel about that particular implementation there, that they even can't see the encrypted data. So a lot of different scenarios where this could be useful. I'll kind of skip through these so that we can get into the demo in the last few minutes here. Here's how there's two types of encryption that we can use here. There's randomized and deterministic. What that means to us is you see in the first example there, if I encrypt the value 1 through 9 with a randomized encryption, every single time I write that data to my table, it's going to show me a different hash value. It's going to show me a different var binary encrypted value there. Okay. With a deterministic encryption, it means if I write the value 1 through 9 to the database 6 or 7 times, I'm always going to have the exact same var binary encrypted hash out the other end of that. Okay. You'll see a couple of different operations that we can and can't do there. So if we have randomized encryption, we can't do joins and we can't do where clauses. Okay. There's just no ability to do that inside there. Deterministic, on the other hand, it does allow you to do those where clauses and joins. So another thing to keep in mind whenever you have deterministic versus randomized encryption, just keep in mind the amount of data that you have inside these fields as well. So let's take gender, for instance, male and female. If I put 2 genders in there and I encrypt the field and I use a deterministic encryption, but I have access to the name. So I've got first name, last name, and gender inside my table, and gender is deterministically encrypted. It's going to be pretty easy for somebody to go in there and figure out which records are the male records and which records are the female records, because they're going to go and they're going to see names like John and Jose and Steve, and they're all going to have the exact same encryption value. Whereas if I go in and I put in randomized and I look up records for Susan and Karen and Susie, or Susan twice, every single one of those records is going to have a different encrypted value there. So keep in mind a couple of things. 1, do I need to do where clauses? 2, do I need to do joins? And 3, how secure do I really need that data to be inside my database? Okay. A couple of different levels of keys. Again, we have the column level encryption key and a master level a column encryption key and a column master key. Those 2 pieces together are going to be what we use to retrieve the data. The column master key, that can go in a couple of different places, like the Azure Key Vault or the certificate store locally on your computer. I'm going to show you the certificate store. And then the column encryption key is actually stored inside the database. What that actually means to us here in real life is that when a user goes and they issue a command out to the database, let's say that they're going to, in this case, select social security number from the patients table. The social security number inside the patients table is in this particular scenario, is a encrypted field. So what's going to happen is I'm going to run that query. Again, the key here, as kind of is the theme so far, no application changes need to happen here. You just have to make sure you're using the correct version of that client driver, that ADO.NET driver. We're going to run a query, just select social security number from patients. What's going to happen is that data is going to get sent back over to the client driver, fully encrypted with a couple of extra pieces of information here. You'll see it's going to give us the column, which is social security number. It's going to give us the column encryption key value, which again, if you remember, I said is stored in the database. It's also going to tell us where the master key is stored, because keep in mind, the master key will not be stored inside your database. That would be a terrible security model if the master key was stored right next to the encryption key. Okay, so it's going to tell us where that master key is stored. In this case, the certificate store on my computer. Again, that could be the certificate store, could be a hardware store, or it could be the Azure Key Vault. And then it's going to tell us where inside the certificate store, in this case, that is, as well as the encrypted column. So those 5 pieces of information are going to be brought back. Yes, the encrypted, so I'm going to send the name, the encrypted key value, the location of the master key, the actual master key path, and then the actual encrypted value. All that data, keep in mind, nothing is sent in plain text here. That's all encrypted over the network into the client driver. The client driver then is going to take that information and it's going to go contact the key store, again, whether that's the Azure Key Vault or whether it's the local key store here, and it's going to pull back the master key and use that master key to decrypt the data and then put the data into plain text into your application. So only once the data comes out of the other end of that ADO.NET driver is it actually going to be decrypted. Okay? Same exact thing happens if I were to go and write a record into the database. Before it would allow me to send the data from the client driver into the database, it would see that it's going to be putting the data into an encrypted field. It would go contact the key vault, the key store there, and it would encrypt the data and send encrypted data over the wire into the database. So no matter whether you're inserting data into the database or pulling data out of the database, all of the data outside the application past that client driver is going to be encrypted. Okay? Again, the ADO.NET driver, .NET 4.6 or later there, and all the data outside the application is going to be encrypted here. And let me show you a quick example of this. So, and I've put together a little C# application here just to kind of illustrate what's going on here as well. So let me go ahead and start a new query window here. I'm going to use just the AdventureWorks table here, or the AdventureWorks database. I'm going to create myself a table in here called Demo Always Encrypted, and actually I need to pull back, not that, I need to pull back my encryption key. So I've got these actually named incorrectly here, so CEK Auto1 is the name of my encryption key. A couple of ways that we can actually create the encryption key. We can right-click in here and say New Column Master Key, or probably the more secure route here would be to create the encryption key, have somebody in your organization create the encryption key, and then pass that over to the DBAs, create this master key here themselves using PowerShell rather. That way the DBAs don't have access to both keys to the fort there. In many organizations, it's probably going to be the same person creating the keys as the DBA to manage the keys here in the database. But if you do have that division of responsibilities, you're going to want to generate the actual certificate and the keys using PowerShell and then pass that information over to the DBA. So I'm going to go ahead and just for time's sake here, I'm going to use just the encryption key that I've already got created inside the database here. Both of this is using the local keys, the local certificate store on my computer. So I'll create my database here, or create my table. And then when I try to insert a value into that table, into any of the encrypted columns, which you'll see both of these columns, the birth date and social security number. One is randomized encryption, the other one's deterministic. If I try to insert data into there, I'm going to get a failure. And it's going to give me this long error message that essentially says you're trying to put plain text data into an encrypted field. I can put, because those fields are defined as nullable, I can put null values into those. So what I'm going to do is I'm going to create myself just a quick store procedure here. Okay, so that store procedure is already created inside my database. And then this is the store procedure that I'm going to run. If I try to execute this here, even though I'm running it as a store procedure, I get the same error message. It says, hey, you can't go and you can't insert a record into this table because you're trying to put plain text values into the encrypted field. We need to have that ADO.NET driver in there to give us the encryption, to encrypt that value before it goes into the database. So I'm going to pull up my little .NET app that I've put together here, always encrypted. And I'm referencing just that same exact store procedure here inside of this application. So you'll notice that I have added this little piece to my URL here, or to my connection string that says column encryption setting equals enabled. So we do have to have that on our connection string. And then I'm going to insert a record and then select the same exact record back. So that's all we're going to do here. Just insert a record into the table and then pull that same record right back out of the database here as well. Okay, so that's going to give me a pop-up here in just 1 second. Okay, actually, oh, forgot that I had this error message in here. So what this is telling me is failed to decrypt column encryption key using store provider MS SQL certificate store. Basically what this is telling me is, hey, putting the encryption enabled on this connection string isn't enough. If I go over here to my certificate store on my computer, I don't actually have the proper certificate inside of here to run this query. Okay, so what I need to do is I need to import the certificate, which is in here, always encrypted. Okay, this is the one provided by Microsoft as part of the AdventureWorks sample. The password here is always encrypted actually. next, finish. And now that I have that certificate here inside my certificate store, I can run this query, or I can run that insert query, and then I can pull the data back. So I no longer get that error message saying, hey, you don't have access to do this. If I do this one more time, if I run that again, so I've run this query twice. Okay. What I want to show you, the reason why I wanted to run that twice, is if I go and I select the data from this table now, you'll notice that the birth date column, which I set as non-deterministic or random, you'll notice I get two different values there, even though I inserted the exact same value into both of those fields. Same thing here now over on the Social Security number, because that was a deterministic field, I get the same value back for both of those there. So I'll just run, there is a query that you can run to tell you all the different columns that are encrypted and how they're encrypted and all that kind of stuff. The underlying data in both of these particular tables here is the exact same, but you'll notice because one of these has randomized encryption on, the other one doesn't, you'll notice that the data, the values for every single one of these fields are completely different. Just a couple of queries here because I know we're out of time. Just so you know, you can run group bys here on deterministic fields. You'll get a nice little error message saying, hey, you can't run that on run a group by on a randomized field. Ordering doesn't really work on either one of these. You'll see that the actual ordered data down here for the customer should start at customer 17066. So ordering data on either a deterministic or a randomized field doesn't really work for us. You can do, I could run this query over inside of my application, but again, because I'm trying to pass a plain text value into an encrypted field, it won't allow me to do that here. And but what I can do is I can do joins. So again, make sure that there's no identifying data in other tables that will allow you to determine the users here. So even though this Social Security field is encrypted in both of the tables that I'm pulling from, it will let me actually run this query here, and you can see that the Social Security number is going to be the same in these. But that's only because it's a deterministic join to a deterministic field. If I tried to do that same joining a deterministic field to a randomized field, it's not going to allow me to do that. So, but it only allows me to do this because I'm not trying to pass a plain text value into this. If I tried to switch this and say something like this, this query would then fail on me. Okay, so I can join fields together, but I can't do where clauses again without having that ADO.NET driver in between. I do have some examples of that inside this .NET code here, and again, I'll put that .NET code up on my blog so that you can run through each of these different examples there and see how the deterministic versus non-deterministic works and all that kind of stuff with the always encrypted piece there. So just as a wrap up here, let me put my information back up on the screen for you guys, and I will hand it back over to Rachel, assuming she's still listening.
Borderline. But thank you so much for that presentation. And you have a ton of questions in the chat that I'm sure you're going to answer on your blog. As you mentioned, there is a lot, so enjoy that.
Guess I should probably put my blog on there.
You should. Oh, someone told you, excellent presentation.
Well, thank you.
I know. We try not to do positive reinforcement with him, but that's all right.
Yeah, Rachel's not one for positive reinforcement in general, but
Not much.
So there's my blog up in the top left, just bradleyshack.com. Again, if you have any questions, Rachel's going to send me a list of all the questions here from the webinar. If you do have any other follow-ups, though, feel free to shoot me an email there, just brad.shack@microsoft.com, and I'd be happy to answer questions or discuss pizza preferences.
Pizza. It's carbs. So thank you everyone for joining us, and have a great rest of the week.
Yes, thank you everybody for coming.
Bye.